dot pi. Move this over. Okay, so let's trace it through. I'm trying 2. Okay, I do all of that, and it says, right, 2 is prime, and I've appended 2 to that empty list, so it's now the list containing 2. 3 is prime. 4, nope. 5, nope. Let me add a bit more print to make this even clearer. And that's not going to work. Okay. I'm trying to see if 2 is prime, and the list primes is the empty list. Okay? I've got nothing that could possibly refute this. I've got no counterexamples to try. So I say 2 is prime, and now my primes list is the list containing the number 2. It's the prime I've found so far. Now I try 3 with that. Okay, that does not divide evenly into that. So 3 is prime, and I add it to the end of my list. Come around again. I try 4. That one divides evenly into it. So 4 is not a prime, so I'm done. Try 5. Try 6. That divides evenly in. Try 7. Yep. Try 8. 2 divides evenly in. Try 9. 2 doesn't, but 3 does. So I'm done. Okay? And you can see how this list is growing slowly, but these are the only values I'm ever testing against that. And to prove that, I'll switch back one more time. Testing divisor. And I hope this works, as I expect. No, it still won't fit. Okay. Run the modified program. I'm testing 2 with, I've got nothing to test it with. So I don't even go into that loop, the inner loop. I'll bring up the code again. Okay. Number is 2, so I print out that I'm trying 2 with no primes so far. I don't go into this loop because there's nothing to assign to divisor. That list is empty. Okay? So it must still be prime. Append that to my list and print out 2 is prime, and my primes list is now that. Come around again. Number is 3. Try 2 against 3. Okay, doesn't divide evenly, so I don't see that. Come around again, there's nothing left to assign there, so I'm done there. Come down here, and I've got that. Now try 4. My first divisor is 2. That's the first thing that gets assigned to divisor because it's the first element of primes. Tell you that I'm testing that. It does divide evenly, so I set is prime to false, and I print out that we found a counterexample. And I'm done. Right? I don't execute any of the rest of this code because is prime has been set false. Come around again, and so forth. Now, I think that even if I take out my print statements, which I will do right now, I think this program is less clear than the one that does the extra work. Okay? I mean, yeah, if you know what I'm doing, if you've seen this trick before, then you can read this and go, oh, okay, he's keeping track of, he's doing this, he's doing that. But if I just typed this one in, I would be less confident that this was working correctly than I would be of the other one. So even if I knew this algorithm, which I did, for the couple of minutes it takes me to write the dumber but more obviously correct version, I would probably do that first, so that I've now got something to compare my efficient output against. Okay. And we see this coming up when you're testing scientific codes. Write it the first version so that it's easy to test, and then write the version or versions that are fast enough to be useful. Okay? And a lot of people skip step 1 and then spend much more time trying to find the bugs in step 2 than they would have if they'd spent a bit of time sharpening their axe in step 1.